Hello, my name is Sam. I'm here with Lauren and Tyson, and today we'll be presenting our EECS 498 Tiny Typing Lab. We'll start with a video of our final prototype.
Here you can see a demo of our watch keyboard. To activate the keyboard, I press down on the screen. I can then move the circle around to select a group of buttons. Moving my finger to the edge of the screen, I can select that button and open up a group of letters to type. I can then highlight one of the letters and let go to enter it into the keyboard. I then press the space button to add a space and continue to type the next word. In this case, the word is good. As you can see, the keyboard has suggested the word below. To insert the suggestion, I simply click on the word, and the word is added to the sentence. I then continue typing the next word, which is stimulus. While I'm typing, I make a mistake and enter a keyboard group that doesn't contain the letter I need. To exit the group, I simply let go of the screen, and the watch returns back to its idle state. At any time, I'm also able to back out the word I've entered by hitting the backspace button.
When initially starting this project, we looked towards existing technologies to see how they've implemented watch keyboard. We've examined the Galaxy Watch and noticed that the keyboard that it had was quite hard to use. The buttons were very small, they were in alphabetical order, and we had a hard time typing on it. In contrast to that, the Apple Watch used a character recognition system that worked very well, but it wasn't always accurate. It would misinterpret some characters, and when it did, it was frustrating. After that, we went to brainstorming ideas on a piece of notebook paper. We came up with 3 ideas. The first one was using the character recognition that Apple used. However, we learned that this was too complicated to do in the 1 week given and would likely require machine learning, which if implemented poorly would frustrate the user. Next, we came up with an idea of using a dial that had all 26 letters on screen. This would be easy and fast to use, but it would have small buttons which pose an issue. We also came up with an indirect dial idea where we divide the 26 letters into 6 smaller groups of letters, and when you opened up one of those groups, it would open up a smaller dial. The benefit here being that there would be larger buttons. The downside, though, it would add a layer of indirection and slow down the user. For our first prototype, we decided to prototype the dial. Kind of like a rotary phone, the idea here is that you'd be able to touch down on the screen and then drag it over to the edge of the watch face and select one of the 26 letters. To test this out, we decided to prototype it in Adobe Illustrator, and this was largely to cut down on programming time. To do this in Illustrator, we drew up the GUI for the watch and scaled it down to a 1 by 1 inch square. We then superimposed a finger over the screen and asked different users what their initial impressions of the watch keyboard would be. From the users, we got a lot of feedback. Unanimously, they all said that the buttons would be too hard to press, that it's too small. Because of this, we decided that this prototype was really too difficult to type on and wouldn't be good for our project. So we decided to implement the indirect dial instead.
So for our second prototype, we made an indirect dial where you would hold the middle and drag out to one of the 6 directions, pick which group of letters you wanted, and drag again, pick your specific letter. So this is a video of one of the users we tested our second prototype on.
Oh no.
For each test, there was an average of about 3.8 errors entered, with a raw words per minute of 2.54, and including penalties, our average words per minute was 2.316. Some feedback we got from users was that even though it's laid out as QWERTY, users still need to get familiar with the location of characters. They suggested different types of layouts to help with memorization, such as ABC layout, and they also wanted us to write in the text. One interesting thing they noticed was that sometimes our finger is blocking the second set of buttons. So like if you wanted to select a T, you would drag up to the QWERT, and then you'd have to drag back down to the T, but your finger would block that part. Other users also wanted us to add a dead zone circle and decrease its radius.
Based on feedback from the second prototype, we improved our interface with some guidelines, including a dead zone indicator, a cursor, and most importantly, a word predictor. The predicted word based on the current user's input is shown on the main menu at the bottom, where by typing it, the word will be completed in the text line. The logic behind the word predictor is pretty simple but effective. It uses a prefix tree that looks up the frequency of each word that is an extension of the current prefix. One thing we added is the length penalty so that it tends to predict shorter words with the use of a sigmoid function on the length of the word. We also collected some user feedback on the final prototype. Users feel the word predictor works well. However, they still complain about the learning curve of this keyboard as they need to memorize the position of each character in the submenu. The average drop word per minute for our keyboard is not significantly larger than baseline. We tested the typing speed ourselves and we can reach an average around 5 to 6 words per minute. So when you get used to the keyboard, it will potentially allow users to type faster.